Welcome to 6.2. The only difference between this section and the last section is the population standard deviation is unknown. Okay, so now what we're doing is we're going to have to find our confidence interval in a situation where we don't know the population standard deviation. So this is the actual formula that we're going to be using. And it varies slightly because we're not using our z-score anymore. We're using a t sub c. And that's, I like to think of it like when you figure out the population standard deviation, you divide by capital N. But when you're figuring out your sample standard deviation, you have to divide by n minus 1. So it's kind of like that in this situation. We're dividing by n minus 1 to get our degrees of freedom because we don't have our population standard deviation. So here's this is very technical background behind it. But for purposes of this video, I want to get into math practice so that we understand what we're doing and we can kind of get into the theory behind it in class. So to do this, what we need to do is find our t value. Because remember, before we were finding our z sub c, but now we have our standard deviation. We have no standard deviation, so we need to find our t sub c. To find the critical value for a 95% confidence level when the sample size is 15. So n's equaling 15. What we need to do is subtract 1. We get 14. That's our degrees of freedom. Okay, because the sample size is 15, the degrees of freedom are going to be 14. So you take 1 away from the sample size. Then we're going to look into our table. And our table, this is kind of like a condensed version of it. I'm going to look for a 14 in my degrees of freedom. Go across and find myself my 0.95. And I see that my t sub c is going to be 2.145. So when we look at our normal bell curve, we've been finding the z-scores for the left and the right. This is going to be the same thing. I'm going to use the same value that I've gotten from my table. The negative 2.145 is going to represent the left side, and the positive 2.145 is going to represent the right side. And that's so the 95% will be about the mean, meaning to the left and to the right evenly split. So this is how we're going to find the values for our formula. And again, it's in a table. You're not having to individually calculate it. So find the critical values for t sub c for a 90% confidence level when the sample size is 22. So identify the degrees of freedom. N equals 22. So our degrees of freedom, our DOF, is going to be 22 minus 1. So 22 minus 1 is going to equal 21. So that means my D of F, or my DOF, is going to be 21. So I'm going to look down, 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 down. Here we are. So I want 90%, so I'm going to go to the right, go to the right, go to the right. And here's my value. My T sub C is going to equal 1.721. So this is just replacing our Z sub C that we did in the first section. To construct a confidence interval for a population mean when the standard deviation is unknown, we're going to verify that it is in fact unknown. We're going to find the sample statistics. N is the number in our sample. X bar is the mean for our sample. And S is going to be the standard deviation. Standard deviation for our sample. So that was in section, I think that was 2.4 or 2.5, where we were calculating our standard deviation. But if you remember, you can calculate the standard deviation in the graphing calculator using your vars1 function once you enter the information in the calculator. So you can maintain that in the calculator if you'd like. All right, so then you're going to identify your degrees of freedom, find your margin of error, add it to the mean, and subtract it from the mean. So let's just do it. You randomly select 16 coffee shops. 16 coffee shops, so N is 16. And measure the temperature of the coffee sold at each coffee shop. The sample mean temperature is, so the sample mean is X bar, is 162.0 degrees Fahrenheit. With a sample standard deviation of 10 degrees Fahrenheit. Construct a 95%, so we're looking for 95% confidence interval for the population mean temperature of the coffee sold. Assume the temperatures are approximately normally distributed. All right, so we don't know the population standard deviation, but they were very nice and they provided us with the sample standard deviation. So we're going to use these values, and I defined them as I went through because that's just how I do it. The degrees of freedom equals n minus 1, or 15. So when we're looking up our degrees of freedom, and you can use the table on the previous screen, I'm actually doing it as I'm speaking. The degrees of freedom for 15 at 95% are going to be 2.131. So the T sub C equals 2.131. And again, all I did is look at degrees of freedom of 15, and then I went over to the 0.95 column and I got that value. So we plug it into our formula, and this is our formula right here. T sub C, the standard deviation for the sample divided by the square root of n, and we get 5.3 for our approximate margin of error. That's like the plus and minus value. So to find our left endpoint, we're going to take the sample mean, subtract our margin of error. 162 minus 5.3, and we get 156.7. And then we add to it the 5.3, and we get our right bound. So with 95% confidence, you can say the population mean temperature of coffee sold is up between 156.7 degrees Fahrenheit and 167.3 degrees Fahrenheit. So again, the number one difference in this process is the degrees of freedom and looking up the value on the table. Here's another table that I provided you and I forgot. Keep it handy. All right, so we're going to construct a 90% and a 99% confidence interval for the population mean temperature of coffee sold in example 2. So the first thing we have to do is find T sub C for each of them. So I'm going to do for A, T sub C. Okay, let's just actually, we should probably define our variables. Our degrees of freedom equal 15. Our X bar is 162. Our N equals 16. Our standard deviation for the sample equals 10. I think we have everything. So I'm going to look up the T sub C for 0.9 in my table. The degrees of freedom are 15, 0.9, 1.753. 1.753. All right. So to figure out my E is going to equal 1.753, the standard deviation of 10 over the square root of 16. So go ahead and simplify that in your calculator. Quit, clear. So I'm going to do 10 divided by radical 16 first, and I get 2.5. So 1.753 times 2.5. I'm going to multiply it by 1.753, and I get my margin of error to equal 4.3825. So my left bound, my right bound, my mean. I have 162. 162 plus 4.38 equals my 166.38. And my right bound is 162 minus 4.3825, 157.62. So I can say I'm with 90% confidence the mean temperature of the coffee sold is going to be between 157.62 degrees and 166.38 degrees. So I want you to do it for 99%. Use your table of values and calculate what that would be, and we can talk about it in class when I see you next. Doing it on the graphing calculator, it's very similar to how we did our z-scores. We just need to know, oh, actually I think we have everything that we need to know. So we're going to press stat, go to tests. Now, it's going to be under the z interval. So it should be the next option under the z interval. It's called t interval. I'm going to press enter. we're entering the statistics. So our mean temperature, our X bar is 162. Our standard deviation is 10, so hopefully you're following along with me. Our the number of samples that we collected is 16, and we're looking for 0.99% confidence. Enter. I'm just using the last one that we did that you guys were supposed to solve. So when I do that, I get 154.63 for my left bound, 162 for my X bar, and 169.37 for my right end, my right bound. So that's how you guys can calculate this on the graphing calculator. So we bring it all together. We ask ourselves, is the population standard deviation known? If we know the population standard deviation, then we use our z-score. Okay, and that's where section 1.6.1 rather, I had the scores that were laid out for you, but you can calculate them yourself if you don't remember them or write them down. And for not knowing the population standard deviation, you're going to use T sub C. And in this case, you need to know what the degrees of freedom are to look it up. So that's the primary difference between the two sections. Thanks, guys, and have a great night.